So very good evening to all of you and welcome to BYJU'S Exam Prep, my dear friends, and welcome to the session IIT Kanpur BYQ series, my dear friends. So very good evening to all of you and welcome to BYJU'S. So good evening, Ikra. How are you all, my dear friends? This is the another session. Already I have taken one session on IIT Kanpur PYQ series yesterday, my dear friend. This is the second session on computer networks. Homework question answer 1575 microsecond. Good. So all of you, please join the session quickly, my dear friends, and share the session to your friends also, so that more and more students will join the session. Okay, if you have not liked the session till now, please like the session, my dear friends, and share the session to your friends also. If you have not subscribed the channel, please subscribe the channel also. Okay, so today we will discuss, this is the another session, my dear friends, IIT Kanpur PYQ series GATE 2023 Computer Network Part 2. Computer Network Part 2. सेंड ग्रुप में पीडीएफ पोस्ट कर दो सारी सेशन की. हाँ, पीडीएफ मैं सारे सेशन की सेंड करता हूं अनंत, ऑलवेज. जल्दी से एक बार शेयर कर दो दोस्तों, जिससे कि ज्यादा से ज्यादा स्टूडेंट्स क्या कर ले, सेशन को ज्वाइन कर लें. ओके, so please share the session to your friends also, so that more and more students will join. Okay, now before starting the session, my dear friends, I am Ankit Doila. I have more than 10 plus year of teaching experience. I secured All India rank 159 in GATE, All India rank 119 in NET JRF. Other than the GATE and NET, I also qualified ISRO exam, NELIT exam and UPPCL exam. Area of expertise, computer networks, theory of computation and compiler design. Okay, so are you ready, guys? Shall I start the session? Tushar, good evening. How are you, Tushar? जल्दी से एक बार शेयर कर दो दोस्तों, तभी सेशन में आपको भी मजा आएगा और मुझे भी मजा आएगा. ठीक है, so now this is the question that I have given you as a homework. This is 2015 question, 2 marks question. 2015 2 marks question. This question was given you as a homework. So what is the answer for this question? Can you tell me, my dear friends, what is the answer of this question? If you have already solved, tell me the answer for this question. Okay, two hosts are connected by a packet switch of 10 power 7 bits per second link. Two hosts are connected by a packet switch. Two hosts. So suppose we can say that this is the host 1, my dear friends, host 1, and suppose this is host 2. Suppose this is host 2. Host 1 and host 2 are connected by a switch. Like that. Packet switch with 10 power 7 bits per second links. It means in this question here, bandwidth is given here 10 power 7 bits. 10 power 7 bits per second. 10 power 7 bits per second. What further information given here? Each link has a propagation delay of 20 microsecond. It means in the question itself, propagation delay is also given 20 microsecond. 20 microsecond. Okay, further. Switch begins forwarding a packet 35 microsecond after it receives the same. If any packet arrive at a switch, so it will take 35 microsecond. I want to learn compiler design from you. Please teach me in further session. I will take compiler design also, don't worry. Okay, so actually if any packet arrive at a switch, it will take 35 millisecond to deliver further. So this is here 35 millisecond delay, 35 microsecond. Okay, further what information given? If 10,000 bits of data are to be transmitted, 10,000 bits data are to be transmitted between two hosts using a packet size of 5,000 bits. So actually in the question itself, my dear friends, packet size is given. What packet size given here? 5,000 bits. Packet size is given 5,000 bits. So what they are saying, if 10,000 bits of data, if we are sending data 10,000 bits and one packet size, my dear friends, 5,000 bits. So how many number of packets? Can you tell me? Number of packets we can find or not? So number of packets we can find here, and number of packets we are denoting number of packets. Number of packets we are denoting by capital N. So this is nothing but 10,000 divided by 5,000. Divide by 5,000. So this is nothing but 2. So number of packets will be 2. The time elapsed between the transmission of the first bit of data and the reception of the last bit, it in microseconds. So it means they are asking to deliver the entire data at the destination, how much time it will take to deliver entire data. So this is related to packet switching. Actually, we have some data. We are dividing this data into packets. So how much time it will take, my dear friends? So actually, listen me. I will take an example and explain. I will explain this. So first of all, suppose through the pipelining concept, we can solve this question. First of all, we have to send this packet onto this link. So there will be one transmission delay here. Now packet is moving from here to switch. There will be propagation delay. Again, this switch will transmit this packet onto this link. There is again transmission delay. And now packet is moving here, propagation delay. So time taken to reach first packet, this is nothing but transmission delay plus propagation delay plus transmission delay, and here on a switch there will be some queuing delay, there will be some processing delay also, and also propagation delay. So actually, my dear friends, for any packet switching, I have a one generalized formula. With the help of the generalized formula, you can solve any question. Sir, from where you got this generalized formula? By using the pipelining concept. So I will not derive the formula because it will take lots of time to derive. But I will tell you that particular formula. If after applying that particular formula, you can solve any question. So what is this formula? Total time. Total time to send all the packet. Suppose I am deriving this formula whenever we have x hop, number of hops we are considering x hop, and n packets, and n packets. So what is the generalized formula? X transmission delay and propagation delay. X transmission delay and propagation delay. Plus x minus 1. There will be some queuing delay plus processing delay. PRD. Plus n minus 1 transmission delay. N minus 1 transmission delay. So actually, my dear friend, first packet will take x time transmission delay, x time propagation delay. Why? X time transmission delay, x time propagation delay. Here, how many hops? 2 hops. One time transmission delay here, one time transmission delay here. 2 hops. So 2 times transmission delay. 2 times propagation delay. So here we have 2 hops, 2 times transmission delay, 2 times propagation delay. And my dear friends, if we have 2 hops, only one time it can be switch, it can be router or anything. Only one time queuing delay or processing delay. So I can frame a one generalized formula from this. What is this here? First packet will take x time transmission delay plus x time propagation delay, and x minus 1 times queuing delay plus processing delay, and n minus 1 time transmission delay. And remaining all packets will take only one transmission delay. First packet will take this time here to here, and remaining all packet n minus 1 packet will take only one transmission delay. I will give you a proof if I take a one session on packet switching, but here I am not interested, but because it will take lots of time to give you a proof. So now you can compute, my dear friends, here. Packet size given here, and this bandwidth is also given, so we can find here transmission delay. We can find transmission delay. How we can find transmission delay? Transmission delay is nothing but packet size divided by bandwidth. Packet size divided by bandwidth. Packet size divided by bandwidth. So packet size is nothing but 5000 bits. 5000 bits divided by what bandwidth we have given? 10 power 7 bits per second. 10 power 7 bits per second. So bit to bit cancel here. 10 to 10 cancel. So it becomes like that, 500 into 10 power minus 6 second. So we can say this is 500 microsecond. We can say 500 microsecond. Okay. So जिसने भी सेशन को लाइक नहीं किया, my dear friends, please like the session. Okay. So x, how many hops we have, my dear friends? X hop. This is 1 hop. This is 1 hop. 2 hop we have. Okay. So this x value will be 2. Transmission delay 500 microsecond plus propagation delay is given 20 microsecond or not. Propagation delay is given 20 microsecond. Okay, now plus x minus 1. X value will be 2. 2 minus 1, 1. Queuing delay and processing delay. There will be some delay on a router, queue or processing. But here, my dear friends, it is given in the question itself that 35 microsecond delay at this switch, or we can say router. So queuing delay and processing delay, we can say that this is 35 plus n minus 1. Number of packets we have 2 here. Number of packets how many? Number of packets we have 2. So n minus 1, 2 minus 1, this is 1 into transmission delay. Transmission delay 500. So what we can say this is? It will be 1000 here plus 40 plus 35 plus 500. Okay. So this is nothing but 1575 microsecond. By applying this formula, you can solve any question of packet switching. Is it clear to everyone or not? So जिसने भी सेशन को लाइक नहीं किया, my dear friends, please like the session. Is it clear to everyone? You have to remember only this formula, so you can solve any question related to packet switching. Okay, this is the Raman formula for packet switching. Clear? Now, this is another question that you can see on the screen. Question number 11. Host A send UDP datagram containing 8,880 byte of user data. Okay. Host A send a UDP datagram. This is important point here. UDP datagram containing 8880 byte of user data to host B. Over Ethernet LAN, Ethernet frames may carry data up to 1500 byte. That is MTU equal to 1500. MTU is given 1500 byte. The size of the UDP header is 8 byte. And the size of IP header is 20 byte. There is no option filled in the IP header. How many total number of IP fragments will be transmitted? How many total number of IP fragment will be transmitted? And what will be the content of offset field in the last fragment? They are asking that how many number of fragments it will be repeated, how many number of fragments it will be transmitted, and what is the offset value of last fragment. This is really one of the interesting question of fragmentation, my dear friend. One of the interesting question till now related to fragmentation. You please tell me C for C, 7 and 1110. Okay. So first of all, my dear friends, you know one thing that application layer packet name is masses. Application layer packet name is masses. Application layer forward the packet to transport layer. Forward the packet to transport layer. This. What transport layer will do? Transport layer attach this H1 header and packet name at transport layer. It can be segment or datagram. If we are using TCP, so packet name at transport layer, there will be segment. If we are using UDP, so packet name at transport layer, this is datagram. Okay. Now, data link layer, transport layer, forward the packet to network layer. This entire thing, whatever the data or header, this entire thing is data for network layer, and network layer attach this H2 header. Okay. This is the case. What they are saying that host A send UDP datagram containing 8880 byte of user data. So UDP work at which layer? UDP work at which layer? Transport layer, because TCP and UDP both work at transport layer. So user data given at transport layer, my dear friends, user data given at transport layer, this is 8880 byte. This is 8880 byte. So this message size, ultimately they are saying that 8880. So at transport layer, we have to attach this header also. How much header given? UDP header in the given 8 byte. UDP header always 8 byte. So this 8880 plus 8, this is 8888. This is the data for network layer. And network layer attach H2 header. H2 header is given 20 byte. So at network layer, this is the condition for data. The data size is 4 times 8 and header is 20. Now we have to apply fragmentation. So at network layer, this is the condition. Because fragmentation done at network layer na here. 4 times 8, 1, 2, 3, 4. Now in the question itself given that MTU, maximum transmission unit, this is nothing but 1500. Okay, now so if MTU is given 1500, my dear friends, how much data we can send? Because 20 byte always attach header, because with fragmentation we apply only for data part, not for the header. So this is here, we can say that this is 20 byte data copied. Okay, so maximum data I can send here, because 20 byte header always copied. So maximum data I can send here 1480 or not 1480. Because why? Because 1500 maximum we can transfer. So 20 byte header is attached to every packet always. Now 1480 byte data. First of all, we have to check that 1480 is divisible by 8 or not. It is divisible by 8 or not. If any three number, last three digit of any number divisible by 8, so it means entire number is divisible by 8. Last three digit, divisible 480, divisible by 8, yes. So in the next packet also we can send here. This is 20 and 1480. Again, 20 and 1480. 20 and 1480. Fourth packet also, this is 20 and 1480. 20 and 1480. Now fifth packet also 20 and 1480. 20 and 1480. And this sixth packet also 20 and 1480. 20 and 1480. Tell me one thing, that I have sent how many packets 1480? 1, 2, 3, 4, 5, 6. If all packets are 1500 byte, so 1500 into 6, this will be 9000. But we have 20 less than 20, 20, 20, 20. How many times? Because we are sending 1480. 20 into 6, 120. So 9000 minus 120. 9000 minus 120. This is nothing but 8880. So in the first 6 packet, we have sent 8880 byte of data. But this, how much data we have? This is data, this is header. How much data we have? 8888. So in the last packet, this 20 byte header, only 8 byte data is remaining. It is remaining or not? Nisa, good evening. It is remaining or not? Yes, sir. So how many fragments we have? This is how many fragments we have? 1, 2, 3, 4. This is 5. This is 6. This is 7. 7 fragment. What they are asking? They are asking the offset value of last fragment. So they are asking the offset value of last fragment. They are asking offset. So how we can find offset? Number of data byte ahead of this fragment. Number of data byte ahead. So 1480 into 6. 1480, 1480, 1480, 1480 into 6. Number of data byte ahead. So this is nothing but 8880. Okay. So this is nothing but 6 into 1480. Divide by 8. So this is nothing but 8880 divided by 8. So this is nothing but 1110. This is the offset value. Is it clear or not? So it means the correct answer for this question, will be 7 and 1110. This is the correct answer for this question number 11. This is one of the one of the best question of fragmentation till now in the GATE. Okay. So जिसने भी सेशन को लाइक नहीं किया, my dear friends, please like the session and share the session to your friends also, so that more and more students will join the session. This is the question number 12. This question GATE 2015. This is the question GATE 2015. First of all, read the question. Read the question number this. A link has a transmission speed of 10 power 6 bits per second. Read the question. Transmission speed, it means bandwidth is given. Bandwidth is given here. Okay. Bandwidth how much given here? 10 power 6 bits per second. 10 power 6 bits per second. Read the question and collect the data first of all. It use packet of size 1000 byte. Packet size we always denote L. This is nothing but 1000 byte. So 1000 byte, we can say 8000 bits. It is better that we convert into bits. Now further what is given here? Assume that acknowledgement CN में कितना क्वेश्चन आता है? You can say that around 11 to 12 marks CN आएगा every year 11 to 12 marks CN. Question maybe most of the questions are 2 marks question in CN, most of the question. Okay. Assume that acknowledgement has negligible transmission delay and its propagation delay is same as the data propagation delay. What they are saying that assume that acknowledgement has negligible transmission delay. Yes, acknowledgement has negligible transmission delay and the propagation delay of acknowledgement is same as the propagation delay of data. It always happens. The propagation delay of acknowledgement and propagation delay of data both are same always. Okay. Next, also assume that processing delay at node is negligible. Processing delay also negligible. The efficiency of stop and wait protocol is set up to exactly 25%. Efficiency is given, my dear friends, how much? 25%. 25%, we can say that this is 1/4. Efficiency is given 1/4. Okay. The value of one-way propagation delay. Value of one-way propagation delay in millisecond. They're asking. Anyone can tell me the answer in the comment box, my dear friends. If you have not liked the session till now, please like the session and share the session to your friends also, my dear friends. Okay. Correct answer. 1/1 plus 2a. AV, I'm again saying that forget this formula 1/1 plus 2a. इस फॉर्मूले को आप भूल जाओ तो अच्छा है. ठीक है. Now bandwidth given, L given, we can find transmission delay or not? Yes sir, transmission delay L by B, length of the packet divided by bandwidth. Length of the packet 8000 bits divided by bandwidth given 10 power 6 bits per second. Bit to bit cancel here, 30 to 30 cancel. So it becomes 8 into 10 power minus 3 second. So we can say that 8 millisecond. 8 millisecond is the answer. Transmission delay. Okay. Why गलत है? गलत तब है जब इस क्वेश्चन में, किसी भी क्वेश्चन में, if processing delay given in the question, queuing delay given in the question, or transmission delay of acknowledgement is given in the question, so this formula 1/1 plus 2a will be fail. Okay. And we have questions also based on this. So if you apply because 1/1 plus 2a, you are saying a means propagation delay divided by transmission delay. So in this formula you can substitute only two value, propagation delay and transmission delay. If in the question queuing delay given, where you will adjust the queuing delay in this formula, where you will adjust the processing delay in the formula, where you will adjust the transmission delay of acknowledgement in the formula. So that's why it's my suggestion, because most of the students remember this formula efficiency 1/1 plus 2a. I never recommend to remember any formula. Most of the students has done mistake by applying this formula. So we know one thing, that don't remember any formula. Efficiency equal to useful time divided by total time. Useful time divided by total time. Useful time divided by total time. What efficiency is given? Exactly 25%. 1/4. Useful time is always transmission delay of frame. Transmission delay of frame or packet, we can say. Divided by total time. Total time is transmission delay of frame plus 2 into propagation delay plus transmission plus queuing delay plus processing delay PRD and plus transmission delay of acknowledgement Now in the question itself, what they have given that? They have given that acknowledgement has negligible transmission delay. So acknowledgement transmission delay is given negligible. Negligible means 0. Equivalent to, you can say, this 0. And further what information given here? And propagation delay. Assume that acknowledgement has negligible transmission delay, that its propagation delay is same as the data propagation delay. Okay, right. Assume that processing delay at nodes also negligible. Processing delay also given negligible. and there is no information given regarding the queuing delay, so we also assume this is 0. Okay, always apply this formula. Now how we can here? So this 1/4 here, transmission delay is nothing but how much it is given? 8 millisecond divided by 8 plus 2 into propagation delay. So we can say that 8 plus 2 into propagation delay equal to 32. So we can say that 2 into propagation delay, 32 minus 8, how much? It is 24 na? So propagation delay will be 12 millisecond. Propagation delay will be 12 millisecond. Is it or not? Is it clear or not, my dear friends? If you have not liked the session till now, please like the session. Propagation delay 12 millisecond. Is it clear to everyone or not? Clear to everyone or not? So I can start next question. Now, this is the question number 13 that you can see. Question number 13 that you can see. Consider a TCP connection in state where there are no outstanding acknowledgement. Okay. Sender send 2 segment back to back. Sender send 2 segment back to back. Back to back. Sequence number of the first and second segment are 230 and 290 respectively. First segment have the sequence number 230 and next have the 290 respectively. First segment was lost. But the second segment was received correctly by the receiver. Second segment received correctly. Let X be the amount of data. X be the amount of data carried in the first segment in bytes. And Y be the acknowledgement number sent by the receiver. Acknowledgement number sent by the receiver. Value of X and Y they are asking. Anyone can tell me the correct answer, my dear friends? Anyone can tell the correct answer of this question? It is also a good question. If you know the entire concept of TCP, then only you can solve. Otherwise, you will always have difficulty. Read the question and try to solve. Read the question and try to solve. What is the answer of this question? इसमें डाउट है ललित यादव? ओके, डाउट तो क्लियर करने के लिए हम हैं, डाउट नहीं होना चाहिए. Now, so actually, my dear friends, what they are saying now in this question, let me show you here. They are saying that we are sending 2 segment back to back. We know one thing, that the sequence number of the segment, this is nothing but the sequence number of the first byte. So suppose we are sending this first segment, because TCP is a byte stream protocol. Okay, so this sequence number is nothing but first byte sequence. Sequence number of the segment is always represent first byte sequence number. So what they are saying, that first and second segment are 230 and 290. So first packet sequence number 230. This is 230. And second segment you are sending. Sequence number represent first byte sequence number. This is 290. So we are sending 2 segment back to back. This is first segment. First segment have sequence number. This is how much here? 230. And this is lost. Second segment they are also sending. This is correctly received. This have the sequence number how much? 290. So tell me one thing, my dear friends, it is really very simple. कुछ समझ नहीं आ रहा. Nisa, if you have not covered the topic TCP, so you always have a difficulty. Otherwise, you will understand each and every concept because you don't know. This is the reason only. So tell me one thing, that if second segment have the sequence number 290, so it means the last byte. Can you tell me the first packet last byte sequence number, what it will be? If second segment first byte sequence number 290, so last will be 289 or not. So in the first packet, what is the data? What they are saying, that X be the amount of data carried in the first segment. So first segment how much data? 230 to 289. This is nothing but 60 bytes. So X will be 60 byte here. X will be 60 byte. It's simple. Now, suppose if first segment got lost, second received correctly. What they are saying that why will the acknowledgement number sent by the receiver? What acknowledgement number it will send? Receiver. What acknowledgement number it will send? So actually, my dear friends, TCP can receive out of order segment, but it send acknowledgement always in order. So if 230 is not received till now by the receiver, so receiver will always ask 230, acknowledgement number 230, that I have not received 230, please send me 230. So this is nothing but Y value. So X value will be 60 and Y value will be 230. So X value will be 60 and Y value will be 230. So which is the correct option? You can see here. 230, 60 and 230. So this is the correct answer. D will be the correct answer. Is it clear to everyone? Is it clear to everyone? जिसने भी सेशन को लाइक नहीं किया, my dear friends, please like the session and share the session to your friends also. Okay. This question is clear to everyone. So I can move next. Question number 13. Question number 13. Now let's see. Question number 14. This question was 1 marks question, 2007. Which of the following protocol? Which one of the following uses UDP as transport protocol? UDP. Which of the following uses UDP? UDP. HTTP, Telnet, DNS, SMTP. So my dear friends, DNS is UDP. DNS is UDP. HTTP, Telnet and SMTP, all three are TCP. DNS, it is really very simple. Okay. DNS means one request, one reply. One request, one reply can be fit in one user datagram protocol. Okay. Now, so actually for this now, suppose I have make this table here so that you can understand here. Application protocols, application port number and transport protocol. So this DNS uses UDP. So this is DNS uses UDP. Okay. This HTTP port number 80 and it uses TCP. Okay. Another. FTP have two connection. One is the data connection. Another is okay. Data connection and control connection. So it is next is this is like that. Okay. TCP. Now POP you can see here. Now SMTP, SNMP. This table is really very, very important. So now you can see here DNS port number 53 transport protocol UDP, HTTP port number 80 transport protocol TCP, and FTP uses two port number 20 for data connection, 21 for control connection. 21 for control connection. This is 21 for control connection. SMTP uses port number 25 and TCP. POP port number 110 TCP. SNMP simple network management protocol port number 161, 162 UDP, and TFTP port number 69 UDP, IMAP port number 143 TCP, and Telnet also TCP. So this is the table. Okay. I will explain you this table in details when I teach the application layer protocol. But now I'm not interested. Okay, because it will take more time. So this table is really very, very important. You can make a note of this table. Now next. Next question you can see on the screen. Consider the following segment. This question was 1 marks question, GATE 2015. GATE 2015. GATE 2015. जो लोग पढ़ना चाहते हैं, मैं कैसे एल्गोरिदम स्टार्ट करूंगा पढ़ना? अरे कर लोगे भाई। एबी डिविलियर्स पता बता दो अपना, ऑस्ट्रेलिया में रहते हो कहीं बाहर? Now this is the question, GATE 2015. Tell me the correct answer of this question. Tell me the correct answer for this question. So please like the session if you have not liked till now. Also, my dear friends, subscribe the channel and share the session to your friends also. TCP connection are full duplex. First point, TCP connection full duplex. Yes, TCP connection are full duplex because we can send the data in both the direction. Client can send the data to server, server can also send the data to client. It means downloading, uploading both are possible in TCP. You can download the data from server, you can also upload the data on server. So it means this is full duplex. Yes, very sure. TCP connection full duplex, it is right, 100% right. TCP has no option because what they are asking here, correct. TCP has no option of selective acknowledgement. My dear friends, TCP can use selective acknowledgement as well as cumulative acknowledgement. What is the meaning of selective? Selective means independent acknowledgement. So TCP can send independent acknowledgement for every packet and TCP can also send cumulative acknowledgement. After receiving group of segments, it can send one segment. And after receiving every segment, it can also send acknowledgement. So TCP can use both cumulative acknowledgement as well as selective acknowledgement. What they are saying, TCP has no option for selective acknowledgement. TCP has a option for selective acknowledgement. So this is wrong here. Okay. TCP connection or message stream. TCP connection or message stream? No. TCP is a byte stream protocol. IP is a packet stream, but TCP is a byte stream protocol. Okay. So TCP is not the message stream. It is a byte stream. So it is also wrong. So only first is the correct option. TCP is a byte stream protocol. It is not message stream protocol. At application layer, is it clear or not? Clear or not? Please like the session if you have not liked. This is clear or not? TCP can use both selective as well as cumulative acknowledgement. And next is TCP connection or byte stream. Okay. So TCP is a byte stream protocol. It is not message stream. Is it clear to everyone? So I can move to next. This is the question number 16 that you can see. Question number 16 that you can see. In one of the pair of protocol given below, both protocols can use multiple TCP connection. Both protocol can use multiple TCP connection between the same client and the same server. Same client and the server. Which one is that? Multiple TCP connection. So actually, just before we discuss now, FTP have two connection. One is control connection, one is data connection. So FTP definitely use two connection. One for sending the control information and one for sending the data. FTP we are very sure. So it means this option does not have FTP, so it is 100% wrong. This option does not have FTP, so it is 100. Sorry. It is also wrong. Now this option have FTP, this option also have FTP. So tell me that HTTP, FTP will be the correct, or FTP or SMTP will be correct. Tell me, see. FTP, SMTP, simple mail transfer, SMTP. No. SMTP, no. HTTP will not use two connection. FTP 100%, one control connection, one data connection. But we have a confusion either SMTP or HTTP. My dear friends, HTTP may use different connection, for different object of web page. If non-persistent connection we are using, because HTTP we have two connection. One is persistent, another is non-persistent. Non-persistent means not a permanent. Okay, suppose if a one file have 10 images, so 10 times connection will be open and close. Okay, non-persistent. So it may use HTTP, it may use different TCP connection if we are using non-persistent. So that's why correct answer for this is A, HTTP and FTP. Is it clear or not? याद आ गया? हाँ याद. So connections are two types in HTTP: persistent and non-persistent. Persistent means permanent. Actually, my dear friends, what is the meaning of persistent and non-persistent? Persistent means permanent. Suppose before 1 year you have opened a Gmail in your mobile phone. Now it is open till now. Gmail, they are not closing your connection. Why? So you have opened a Facebook before 1 year. It is open till now. Now, and suppose you have a user ID and password. Suppose you have a net banking account of any bank. After enter the user ID and password, leave that page ideal for 10 seconds. After 10 seconds, they will close your connection. If you leave that page now, after enter the user ID and password, they will show you the entire account details. You leave that page for 10 seconds ideal. After that, again you have to enter the user ID and password. Are you getting my point or not? So this is called as non-persistent. Connection is not persistent. After some time, server will close your connection. But why Gmail and Facebook are not closing your connection? Because Gmail have some benefit, or Facebook have a benefit if you are online. So that's why they are not closing the connection. But bank does not have benefit if you are looking the bank server or if you are online. Bank have a benefit if you transfer any money or anything. Okay. Same as it is. Suppose if you have if you want to book a ticket from railway server. Okay, so after enter the user ID and password, leave that page for 10 seconds ideal. So definitely they will close the connection, because railway does not have benefit if you are looking to the railway server or if you are online on the railway server. Railway have a benefit if you are booking the ticket. If you will book the ticket, railway have benefit. So railway does not have benefit. So they will close the connection after some time. Are you getting my point? Clear? Now, next question number 17. This is also 2 marks question. 2 marks question. Tell me the answer of this question. 2007. अरे इकरार, ललित दूसरी बात कर रहा है। ललित बोल रहा है सर की, वो तुषार से बोल रहे हैं कि मेरी 4 घंटे की वीडियो है। ठीक है, तुषार कोई सर नहीं है, तुषार स्टूडेंट है। सो प्लीज रीड द कमेंट्स केयरफुली। ओके, आई नो दैट यू ऑल पीपल लव मी। ओके, आप सब लोग मुझे बहुत प्यार करते हो, मैं भी आपको बहुत प्यार करता हूं, बट ओके। Now, this is the question number 17, my dear friends. Question number 17 that you can see. Question number 17. The distance between 2 stations M and N is L kilometer. Distance between 2 stations M and N. There are 2 stations M and N. This is M and N. L kilometer. This is distance L kilometer. Okay. All frames are k-bit long. It means frame size. Frame size. Frame size or packet size, frame size L is given k bits. Okay. Propagation delay per kilometer is t second. This is propagation delay per kilometer. So propagation delay for 1 kilometer. 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 How much it is given here? T second. But my dear friends, what is the propagation delay? Propagation delay, amount of time taken to reach a packet from one point to another point. It means from here to here. If 1 kilometer propagation delay, 1 kilometer time is given t second, how much time it will take for L kilometer? So L kilometer propagation delay will be LT. For 1 kilometer it is T, so L kilometer it will be, how much time it will take reach a packet from M to N? This is nothing but propagation delay. So propagation delay for L kilometer. So propagation delay for L kilometer, propagation delay for L kilometer, propagation delay for L kilometer. Equal to LT. Okay, what further they are saying? Assuming that processing delay is negligible, the minimum number of bits for the sequence number filled in a frame of maximum utilization. Maximum utilization means 100% efficiency. 100% efficiency. Okay, when the sliding window protocol is used. Minimum number of bits they are asking. How we solve this question? Anyone can tell me how we solve this question? Minimum number of bits they are asking. So first of all, if we can find window size, so we can find minimum number of bits also. Suppose window size 8. We are sending 8 packets in a window. So sequence number we require 3 bit. Sequence number 3 bits. Is it not? Now tell me, and don't say that. Again, it's my suggestion. Forget this rule. Forget the formula maximum window size 1 plus 2 hai. Okay, so if efficiency is not given in any question, they're asking window size or they're asking sequence number bits. So we assume that efficiency is 100%. What we assume? We assume efficiency is 100%. So this efficiency sliding window, efficiency formula, useful time divided by total time. Useful time divided by total time. Useful time divided by total time. So we assume that they are asking for 100% efficiency. Useful time is n into transmission delay of frame. N into transmission delay of frame. Divide by transmission delay of frame. Again I am writing the total time. Total time 2 into propagation delay. Plus queuing delay. Plus processing delay PRD. Plus transmission delay of acknowledgement. You have to write this complete formula. This is the total time to send a one packet. Transmission delay of frame plus 2 into propagation delay plus queuing delay, processing delay, transmission delay of acknowledgement. Okay. I banned 1 plus 2 from last year itself. Yeah, it is good, Lalit. If you are my student, so it means ban karna hi padega yaar. There is no information given regarding the queuing delay, it will be 0. There is no information regarding the processing delay, it will be 0. There is no information regarding the transmission delay, it will be 0. Because in the question itself that you can see, assume that processing delay is negligible and remaining information not given. So we assume it is 0. Okay. Now tell me one thing, that how we can find transmission delay? Packet size given L. How we can find transmission delay? Transmission delay is nothing but L by B. Length of the packet divided by bandwidth. Packet length. L is K bits. This is K. Bandwidth. In the question itself, bandwidth is given. Let R bits per second to be the channel capacity. Bandwidth is given R. K by R. K by R given bandwidth. Okay. Now, so this is nothing but we can say that 1 equal to N into 1 equal to N into transmission delay. What transmission delay we have find? Transmission delay. This is nothing but K by R. K by R. Divide by transmission delay K by R plus 2 into what propagation delay we have find? Propagation delay. Propagation delay we have find LT. So it is nothing but 2LT. So how we can find N value? How we can find N value, my dear friends? N value. N value is nothing but K by R plus 2LT and divide by K by R, or not? Yes, sir. N equal to R So this is K plus 2LTR or divide by K by R. So this R to R cancel. So N value we got here. This is nothing but K plus 2LTR divide by K. So if window size, my dear friends, if window size is this, so how many bit sequence number required? If you have window size 8, how many sequence number required? 3. So if window size 8, so how many sequence number required? 3. How? Log base 2. 8 like that. So that's why we say that log base 2 power 3. So this is nothing but 3 log base 2 by 2. Or we always take upper boundary. So this is nothing but log base 2. How many sequence number? K plus 2LTR divide by K. And we always take upper boundary. Why always we take upper boundary? Because if I write here log base 2 8, log base 2 suppose 5. So we got here 2 point something value na. So 2 point something means 3. We have to take upper boundary. So that's why I am writing here upper boundary. Okay. So correct answer log base 2 K plus 2LTR by K. K plus 2LTR by K. Log base 2. Which K plus 2LTR by K. Which option correct here? C option is correct. Is it clear to everyone? Is it clear to everyone, my dear friends? This question is clear to everyone. Question number 17. Question number 17. Clear? No. This is the question number 18. Question number 18. It is really very simple. But I don't know that why this question was asked 2 marks. In Ethernet, when Manchester encoding is used, the bit rate is if you have not liked the session, so please like till now. If you have not liked till now, please like the session. Okay. Ethernet, Manchester encoding. We have 2 types of encoding in our GATE syllabus. One is Manchester encoding and next is differential Manchester encoding. And for both, board rate is half of the, board rate equal to 2 into the bit rate. 2 into the bit rate. 2 into the bit rate. Always remember for this encoding. So board rate is 2 into the bit rate. So what is bit rate, my dear friends? Bit rate is nothing but half of the baud rate. So in this question, what they are asking, bit rate is half of the baud rate. Direct question here. It is really very simple. It is direct question, very simple. Very simple also. So if you have not liked the session till now, please like the session, my dear friends. Okay. Clear? Can I move to next? And this is the question number 19. Question number 19. I am giving this question as a homework for you. Please write in the comment box. But I am giving you some idea also. Suppose two hosts uses TCP connection to transfer a large file. Which of the following statement is false? They are asking false statement with respect to TCP connection. First point: if sequence number of a segment is m, if any packet have a sequence number m, then sequence number of the subsequent segment will always be m plus 1. Is it right or not? Here. First point, it is clear or not? Now I explained to you that suppose in this segment we are sending 100 byte. So TCP is byte stream protocol, we always know here. So suppose we have 100 bytes here, 100 byte, every byte is associated with the sequence number. So if first byte sequence number is 0, so last byte sequence number will be 99. Okay, and the sequence number of this packet, sequence number is nothing but the first byte sequence number. Sequence number of this segment will be 0. Now another segment here we have. This also have 100 bytes. So the first byte sequence number will be 100, and next byte and last byte sequence number will be 199, because we have 100 byte. And sequence number of this packet, how much it is? This is 100. So it will not happen if any segment have sequence number m. So next segment also have sequence number m plus 1. It is 100% wrong यार. मतलब ऐसा सोचना भी पाप है. If sequence number of a segment is m, then sequence number of subsequent segment is always m plus 1, because this line na always, it will not be always. If we are sending only one byte, it may be that. Okay, we are sending one byte, so it is 0. So next segment it may be 1, but we are sending 100 bytes. Suppose I am taking example. So this is 100% false. This is false. This is false. I have given you a hint. Next, if estimated round trip time at any given point of time is t, if round trip time is t, the value of retransmission timeout timer, value of timeout timer is always set to greater than or equal to t second. It means they are saying that value of timeout timer is greater than the timeout timer. Now next, third, size of the advertised window never change during the course of TCP connection. Yeah, it will not change. Advertised window always change. Why? Actually, you know one thing, that suppose now initially, suppose this is the receiver have buffer space, suppose here 1000 byte. Okay, now first suppose you have sent the data here 3000, data equal to 300 byte. So what it will be, 300 byte will be buffered here, 300 byte. Now how much space it have remaining here? 700. So it will send a message that now my advertisement window is, now I can receive maximum data 700. You say okay, not a problem. Next time suppose you have sent data equal to here 400. So again this 400 will be buffered. Again this is 300 already buffered. Again this 400 will also be buffered. So how much remaining here? 300 remaining. Again it say that now my advertisement window is remaining 300. Do not send more than 300 byte. It always be. अरे यार मैं solve कर दिया क्या पूरा? So it is false. Okay, now I am not giving hint. 1 and 3 is false. ये तो solve ही हो गया. Because there is no option have 1, 2, 3, 4. If there will be 1, 2, 3, 4, there will be, because 1 and 3 only. 1 and 3 very sure. This is saying 3 only. So it is wrong, because 1 and 3, 2 and 4. This can, 3 must be na. In this 3 there is not. It is not correct. वो खेल हो गया पूरा. Homework चाहिए था. Okay, I will give you homework also. Don't worry. Okay. So this is correct answer for this is we can eliminate by using the elimination technique. We can solve this. Only this is. Now let's take a homework. Oh yaar, homework is no homework. Okay, this question I have given you as a homework. So thank you guys. Bye bye. Okay, I will see you. Now there is one special announcement, my dear friends. Tomorrow I think Sridhar sir will start with the C programming. Okay, same time at 8:30 p.m. and after 15th August, means from 16th August at the same time 8:30 to 9:30 every day Monday to Saturday. I will continue the computer network series, because in the computer network which I have started, I have covered first introduction to IP addressing, second classful addressing, third ranges of IP addresses, next problem solving on IP addressing, and next session problems in computer network, next session types of communication, next session problem solving on types of communication. So, and next topic of this series will be subnetting. So on 16th of August, I will start subnetting, okay. And after first class, I will start subnetting, and later subnetting 10 categories, category 1 to category 10s. And after, I will take 4 sessions on problem solving on subnetting, part 1 to part 4. And later, I will come to the classless addressing, and after that, supernetting concept, okay. So entire we will cover, okay. So the series which I have started now, computer network full course, I will continue from 16th of August, okay. Because up to 16th August, this series will be continue IIT PYQs for each and every subject, okay. So after 16th, I will continue the computer network, okay. So don't forget to join tomorrow also, and from 16th of August also, okay. Prajwal, thank you. So thank you so much, my dear friends, for attending this session. I will meet you, okay, on 16th of August. Thank you. Bye-bye.